Hi. So in this lecture, we're going to learn how to solve the problem searching in a rotated sorted array. Now, this is a very important problem when it comes to interview point of view, and this has been asked in many top companies, top product-based companies, multiple number of times. So I would strongly recommend you to first try this problem yourself, right? And try to solve it yourself. And if you're not able to solve, then come and watch this video. And even if you're able to solve it, come and watch this video, and maybe like you learn something new, right? So, but definitely try this first and only then watch this video. Okay, so let's quickly take a look at the problem statement. So the problem statement is we are given a sorted array A of n distinct integers. This is very important. There are n distinct integers, right? Which is rotated at some point, right? And we are given an element key. The task is to find the index of the given element key in the array A. Okay, so one thing that is very important in this statement is n distinct element, and also it is rotated at some point. What do we mean by rotated? If you see this example, right? In the sorted array, what happens in a sorted array? It is 1, 2, 3, 5, 6, 7, 8, 9, 10. It would have been in a sorted array 1, 2, 3, 5, 6, 7, 8, 9, 10. But it has been rotated by some places, right? So it has been rotated by 3 places. So what happens is here 1, 2, 3 comes at the end, and 5, 6, 7, 8, 9, 10 comes at the beginning before 1, 2, 3. So that is the meaning of rotation, right? You are rotating the elements, right? So that is one in the first rotation. What exactly happens? Let's quickly understand this. So what exactly do we mean by rotation? Let's understand that, right? So uh, we have, let's say, 1, 2, 3, 4, 5. This is the array. Let's rotate it. Rotate means like this, the first element goes to the last, and everything shifts to the left by one place. It can be either left rotation or right rotation. In right rotation it happens the other way, like 5 will come at the front and others will be shifting to the right by one place, and this is the left rotation, right? So let's do left rotation only. So what will happen after this? It will be 2, 3, 4, 5, 1. Let's do a rotation again. Second rotation, it will become 3, 4, 5, 1, 2. Right, let's do a rotation again. It will become 4, 5, 1, 2, 3. So after 3 rotations it is like this. Similarly, after 4 rotations again we'll rotate, so it will become 5, 1, 2, 3, 4. And after 5 rotations it will become, again this goes to the right, 5 rotations it will become 1, 2, 3, 4, 5. So if you see, after 5 rotations it is becoming the array it was, right? So that is there. But I wanted to explain you what exactly do we mean by rotation, right? So I think you have got the idea. So it has been rotated by 3 times, right? If you see this array, it has been rotated 3 times to the left, and we have this. Okay, so we have to find the given element in the rotated sorted array. That is, we are given the key 10. We have to tell that 10 is at index, this index, right? 5, at index 5. So 1, 2, 3, 4, 5, 6, 7. Is 0 based indexing 5? Okay, and if it is not present, we'll do -1. So that's the idea. We have to do it in order of login time and order of one space. Okay, let's understand how we can do this. Yeah, so we have the array here. Let's draw a bit. Let's say 4, 5, 6, 7, 1, 2, 3. So this has been rotated, right? This is rotated. Okay, first thing, how do we search for element? Let's understand this. How do we search for element? Let's say we know how many times it has been rotated. So let's say we know that this is the pivot, right? Pivot means basically the point where it has been, like, which is the rotated starting of the rotation or starting of the array. So this is the starting of the array, right? 1, 2, 3. Actual array was 1, 2, 3. It was the sorted array, right? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. This was the actual array, but it has been rotated some for some number of time. So we have this, this, right? So this will, we will be referring to this as the pivot, pivot, pivot. Okay, let's say we know this pivot element, or which is the index at which pivot occurs. So can we tell where does the index, let's say where does the element lie? Let's say element is 6. Where does 6 lie? Can we tell this? Think about it a bit. So what happens here? 1, 2, 3. This part is increasing. From pivot till the end, this part is increasing. So definitely we can do one check, that is, if the element, that is 6, and if you think about it, 3, this last element is less than 4. 3 is less than 4, right? And that makes sense because 3 was actually before 4 and it has been rotated, so it went after. So 3 is less than 4. So if we see the pivot or the element E, if E is greater than the last element, right? If E is less than the last element, less than equal to, then the pivot will lie in this range. That is, then the element will lie in the range of pivot to n minus 1. That is in this segment. In other words, basically in 1, 2, 3, like this is the rotated part, right? So if we know that the element is less than 3, we know that the element will be in this part. So that is what we are exactly telling. This part is the rotated part, pivot to the end. So if the element is less than equal to the last element, we know that the element will be in this part. If the element is greater than last, so we know it will be in the range of 0 to pivot minus 1. Because 0 to pivot minus 1 will contain the greater elements, right? And both of these parts are independently sorted. Both of these parts are independently sorted, right? 1, 2, 3 is sorted, 4, 5, 6, 7 is sorted. So we can do a binary search. Once we identify which part it belongs to, we can do a binary search on that part and quickly figure out if the element exists or it doesn't exist. Okay, so that's the idea that will follow. But the only concern here is, how do we find this pivot point? How do we find this pivot point? Let's understand this. If we are able to find this, we can easily do a binary search after that. Okay, let's understand how do we find this pivot point. What is the property of a pivot point? All the elements, right? So basically, again, what is the pivot point? 1, 2, 3 was here, and after that 4, 5, 6, 7. These 1, 2, 3 has been rotated and kept and comes at the back. So the property of the pivot, all these elements, see, all these elements are less than 4, and 4 is what? 4 is the starting element of the array, of the rotated array. So the property of the pivot point and all the elements after the pivot point will be that, let's call them A of x, where x is greater than equal to pivot, will be less than equal to A of 0, or rather will be less than A of 0. That this part is very important, right? This part, the condition that we had, that all the elements are distinct, that is very important. We can tell this, that A of x is less than A of 0. If it was equal, then we would have difficulty in doing difficulty in deducing that which one is the pivot point. But as that's not the case, we can easily tell that A of x is less than A of 0 for all the x greater than equal to pivot, right? Which is true, right? A of 0 is 4, 1, 2, 3 are less than A of 0, 4, right? So that's the property. So let's say we have a predicate function, right? We have a predicate function P of x, and it tells whether A of x is less than equal to or less than A of 0. A of x is less than A of 0, right? So what will be the array? What will be the array based on predicate, right? So let's call it the predicate array. Let's call it a predicate array. So the predicate array, it will be something like this. Initially, all of them will be false because all the elements will be greater than A of 0, until we find the pivot element. From the pivot element, it will become true because all the elements are less than A of 0, right? So we have a false, 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 true, true, like this array. We have to find the first occurrence of true. This will be the pivot, right? And how do we find the first occurrence of true? We can use binary search for this. Again, we have learned about how to use binary search on an array like this. So what we'll do is we'll do a binary search. So let's actually do that. So our low will always point to a false, our high will always point to a true, right? So what mid, let's write the indices down: 0, 1, 2, 3, 4, 5, 6, 7, 8. So what is the mid? Mid will be 4, so mid will be pointing to this one, right? And let's get rid of let's get rid of this one as of now. Okay, so we have this mid. So what is P of mid? We'll call what is P of mid. P of mid will give us false. That means our answer lies to the right hand side. So what we'll do is we'll make low will make low point to mid. Again, low will always point to a false, right? Low will always point to a false. That is what we have to ensure. So what is the best place where low can sit? Low can sit because A of 4 is false. So low can sit here. So low sits here, right? Now again, mid, 8 plus 4 by 2, that is 12 by 2, that is 6. So what is P of 6? P of 6 is true. That means definitely the answer lies to the left hand side. So our high will be sitting at 6 and high will always sit at 2. So high can sit at 6. And 6 plus 4 by 2, 5, we get P of mid. So 5 will be true. So our low, again, our high will sit at 5. And our loop ends here, low less than high minus 1. Our loop ends here. If you see, the loop ends at a false and true, this point, right? So high points to the first occurrence of true and will return that, and low points to the last occurrence of false. So we'll return the first occurrence of true. So this way, with high, our high becomes the pivot, right? And once we find the pivot, we can easily do a binary search on either one of the part, and we can determine whether like if the element is there, or if the element is there, we can determine the index as well using binary search. So let's try to write the code for this. So we'll go to the problem statement. Yeah. Okay. So let's go for a full screen mode. First of all, we'll do a bool predicate, right? Int x, and here we'll pass the int a. Okay. So we'll check if a of x return a of x less than a of 0. A of x is less than a of 0. That will be the predicate function. So what we'll do here is we'll do low equals to 0, high equals to ending index. You have to search the key in this string. Okay, low equals to L, actually it will be low equals to L, high equals to H. Okay, now what we'll do is first of all we'll check if P of high is true. If P of high is true, if P of high is not true, it means that what? The last element. What does P of high again mean? A of high, that is the last element, is not less than A of 0. That means that's why it is not true. That means the array is sorted. It is not rotated, it is just sorted, right? So in that case, we'll just do a simple binary search. So let's write the code for binary search as well here. Int find element int a, and here we'll pass in the range in which we want to find the element. Int low, int high, right? So while low less than equal to high, int mid equals to low plus high by 2, if, and also we need the key as well, right? Int key, if a of mid equals to key, return mid, else if a of mid is less than key. That means our answer is on which direction? A of mid is less than key. Our answer is on the right. So low equals to mid plus 1. Else high equals to mid minus 1. So this is the standard binary search for finding an element, and we'll just return -1 if we don't find it, right? If we don't find it, we'll just return a -1. So in this case, we'll just return find element. And in array A from L to H, and key will also give. Okay, so this is okay. Else it means it is rotated, right? So else means it is rotated. So first thing what we have to do is find the pivot. So find pivot, right? So we'll do a binary search for this. So int y low less than high minus 1, and let's keep this in bracket. Int mid equals to what? Int mid equals to low plus high by 2. If p of mid, if p of mid is true, and also we have to pass p of high and a as well, right? It takes a as well. P of mid comma a is true. In that case, high equals to mid. We have already discussed this. Else low equals to mid, right? Okay, so we have completed the binary search. Now the pivot is where? The pivot is at high. So let's write it down here. Pivot equals to high. Okay, now we want to find which part the element belongs to. So we'll check here. If a of n minus 1, if a of n minus 1 is greater than equal to the given key, in that case we'll return find element in array from low, that is from pivot to, sorry, if a of h, let's call it a of h, the last element, pivot to h and key, else return find element a 0 to pivot minus 1 and key, pivot minus 1 and key. So yeah, this should be the code, right? So let's quickly once check if this is compiling. We'll quickly check that. Completed output is 5, expected is also 5. That's running. So let's try to submit this now. Okay, so yes, so it has worked on all the test cases. So this code is working fine. Thank you.